welcome to the lecture on Module 15, the application layer. That's the 7th layer of the OSI model. So you've worked yourself up all the way from the physical layer all the way on up. So here we're going to talk about how to get information between one device to another. So basically, the application layer, we're going to talk about some of the functions of the application layer. Rolled into this is the presentation and the session layer. The TCP/IP model kind of rolls those all together. So you kind of get a little bit of a few other things rolled into this. So we'll look at peer-to-peer networks, we'll look at different web and email servers, we'll look at IP addressing services, and then some file servers. And those are probably some of the biggest applications that most of us that we use. So if I break this lecture, maybe let's see. So as we remember the application layer, you got the OSI model, which is, this is where I said that the session, presentation, application layer all get rolled into the TCP/IP model. And some of the services that are in there, as you can see, their domain name service, hypertext protocol, which is what you do the internet access with, simple mail transfer protocol, post office protocol, DHCP, the dynamic host configuration protocol, file transfer protocol, and Internet Message Access Protocol, IMAP, right? So those are some of the major applications that we use pretty much day to day. So just knowing that, like I said, the TCP/IP model has 3 layers of the OSI model rolled together. So we'll go through some of those today. So now if you look at the presentation and the session layers, now from the presentation, we're kind of working our way down a little bit. Presentation layer has basically 3 primary functions. It's worries about formatting and presenting the data at the source device. Now, it's responsible for compressing data if it needs to be, encrypting the data. So it's just saying, how am I going to get the data from point A to point B? So things that you've seen and used, JPEG, MPEG, PNG, all of those are presentation protocols just to make sure that the data gets put in a format to allow it to get transmitted over the internet. Now the session layer, as the name implies, it basically only worries about creating and maintaining dialogues between source and destination applications. So it just initiates some dialogues, tries to keep them active, restarts them if it gets disrupted, or idles them if they've been idle too long. So just some things that are important, but just not a long list of them there. Now some of the basic or main TCP/IP application layer programs is, first one we got here is DNS. Now when you see the way this is laid out, you see DNS, so you got to understand the name, but also look at the transport layer information as well and what it does, because you may see that on a test. I'm not saying it's a possibility. Okay, it's a high probability. So the domain name service, basically it just translates domain names such as cisco.com or cccti.edu into an IP address. So it takes the logical and puts it into kind of a physical address, so to speak. Even though, never mind. So keep in mind that DNS can run on both TCP or UDP, and it uses port number 53. So keep that in mind. With the host configuration. There's a couple of them there. There's a bootstrap protocol. We don't use it that often, or at least you don't see it that much, only because DHCP took over its main role. But just know that if it's asked, it is a UDP protocol, runs on client side on port 68, server side on port 67. It enables a diskless workstation to discover its own IP address. But like I said, it's been kind of replaced by DHCP, but some things didn't change. DHCP is still UDP. On the client side, it's port 68. Server side, it's port 67. So you've got to keep that in mind. And then, as we know, since we've used it probably forever, it dynamically assigns an IP address to be reused. And when you're done, it puts it back in a pool. So the next time you log in, you may not get the same IP address, but it automatically makes sure that you have an IP address every time you log in. Now, when it comes to email, there's a couple of different protocols. You've got the simple mail transfer protocol, SMTP. That's a TCP protocol, port 25. It enables clients and servers to send email back and forth. You have the post office protocol, and there's actually 3 versions of it as of this broadcast. So you got a POP3, and that runs on TCP 110. It enables clients to retrieve email from an email server. So it downloads all the email to a local server. Most of us today are running probably an IMAP, an Internet Message Access Protocol, which enables clients to access mail stored on a mail server, but all the mail is maintained on the server. When I first started out, POP3 was the email server of choice, and you'd go in, you'd hit your email, and it would download every bit of information to your computer. And then you'd answer all your email and you'd upload it. Whoops. And then it uploaded everything to the next day. So, but most of the day are using an IMAP, so you want to keep in mind. So, remember, they're all TCP. Pay attention to the port numbers, and make sure you understand a little bit of what happens with each of the ones. I think you want to keep in mind that POP3 retrieves emails, but it just downloads it, clears it off that server, where an IMAP actually maintains this data on the server. So keep that in mind. On the transfer protocol, there are basically 2. There's file transfer protocol. Now, what makes this one unique is it uses both ports 20 and 21. So just keep in mind that it uses 2 ports, one for data, one for control. Now, being a TCP protocol, FTP, that makes it reliable, it's connection oriented, it makes sure there's an acknowledgement of the file's been delivered and delivered correctly. Then there's a trivial file transfer protocol, and as you can see, that's a UDP, and it's client 69. So that's the port number 69 on the client side. But it's connectionless, it doesn't care, it transfers it, makes the best effort, the same thing as UDP does. So it's less overhead, it's a faster transport, but if something happens, you won't get all the information that, you may not get all the information you want to, and then you'll have to deal with it once you get it. And then you got web services, and here you've got HTTP and HTTPS. They're both TCP protocol. Hypertext uses ports 80 and 8080, and then HTTPS for secure is a TCP protocol, but it uses UDP ports 443. So it uses encryption to secure that communication. So those are some of the key applications you do with this layer. So what I want to do then is let you do the test quiz, and let me go back to, and we'll do the next video on peer-to-peer.